Alright guys, it's time to learn some more about sandy shores. Make sure that you went and took attendance first. If you didn't, pause, go take attendance, and come back and take the notes. Okay, label your notes nice and ginormous across the top of your paper. Sandy Shores, Part 3. You can handwrite them and submit pictures to Schoology, or you can write them in Notability and submit it to Schoology. But either way, your handwriting, your own notes submitted to Schoology for me. Alright, so let's talk about beaches. You can find beaches on rivers and lakes, but the ones that we really are interested in are the ones in the ocean. So we've got this narrow, gently sloping strip of land that lies along the edge of an ocean, in our instance. Now usually you're going to find sand, but sometimes there's rocky shores that have pebbles and lots of fragments of seashells that cover the beach. Remember that the beach is made out of products from erosion and weathering by wind and water that wear away at the land. I mean, a giant rock or boulder can be worn into tiny little grains of sand over time. Remember that the main thing that moves them are wind and waves. Okay? Alright, so you're at the beach. There's two types of wave action. You have the swash, whoosh, when the water comes up on the beach, and then the backwash, whoosh, as the water goes back down the beach. Swash, backwash. Swash, backwash. All right, they sound really similar, so don't confuse the two. Okay, so waves move sand every time they break along the shore. Large waves tend to remove a lot of sand. Small waves deposit sand because the energy that they're carrying determines whether or not particles will be picked up and moved or deposited. All right, so look at this one. Are they large waves or small waves? The top one is when you had large waves, like a storm, like a hurricane that came and took away a whole bunch of the beach. We've seen this after hurricanes. Now, on the other hand, when you have really, really small differences in these tiny little waves, you're going to get like a nice long beach because the small waves are depositing sand. Ocean tides and currents can carry sediment a few meters or hundreds of kilometers away. It just depends on the strength of the currents. All right. The tides and the currents are the main ways beaches are created, how they change, or even if they're destroyed, depending on the size and the strength in the waves and the currents. All right, so there's different types of beach. The first beach we're going to talk about are called reflective beaches. These have really low energy waves. The waves do not get more than about 3 feet high. They have really big sediments, so it's not sandy. It's more pebbly like this. Okay, not the best thing you want to make sandcastles in. It's going to have a very low difference between high tide and low tide. Maybe from like where you can see where the lighter sand is to the darker sand. Okay? And they're going to have a steep slope with which waves are going to break kind of like at an angle and then reflect back off the beach. That's why they call them reflective beaches. Alright, so the second type of beach is an intermediate beach. So now your waves can get up to like 6 feet. Fine to medium sand. It's not a steep slope, but it's not a gentle slope either. It's kind of just right there in the middle. That's why it's called intermediate. And you'll get sandbars and rip channels here. And I know you guys know what sandbars and rip channels are because we live in Florida and you've been to the beach. So the types of beaches that we have here in Florida are intermediate beaches. Hint, hint. All right. And then the next type of beach is called a dissipative beach. And here is your high wave action, more than 6 feet. These are going to be teeny tiny little fine grains of sediment, of sand. Going to have a very high difference between high tide and low tide because it's a super gentle slope. Okay, and it's called dissipative because the wave energy as it comes in on that long gentle slope, the energy dissipates as it moves across that surf zone. More about surf zones later. Alright, so those are the 3 types of beaches that you get. There is a transition zone between the land and the marine environment, and it's not as simple as like this is water and this is land. Okay, so every beach has its very specific profile. Beaches can be warm, they can have lots of vegetation, they can have mangroves, or they can be cold and they can be rocky. It could be in the Arctic or the Antarctic where it's frozen most of the year. It's just going to depend on where you are in the world. So let's talk about some major types of definitions that you're going to find on a sandy shore. So, technically, the shore is the zone that lies between the low tide and the highest elevation on land that can be affected by storm waves. Okay? The coast is going to extend even further than that as far as ocean-related features can be found, and it could be several miles. Okay? So let's look really quick right here. Coastal area. See how far the coast goes? And then where it says beach and shore, it's that whole area there between the breakers and the coast. Okay? Alright, so the coastline is the boundary between the shore and the coast. That one's easy enough. Alright, so the shore is divided into the back shore and the foreshore. Foreshore. Okay, so it makes sense that the back shore is in the back and the foreshore is in the front. Okay, so back shore is above the high tide line and it's covered with water only during storms, so not usually wet. Okay, the foreshore is a portion exposed during low tide and submerged during high tide. So this is the part where the tides are going in and the tides are going out in the foreshore. Okay, now the shoreline can migrate back and forth with the tide, and it's at the water's edge. It's the precise boundary where water meets adjacent land. Okay, so see right here where it says shoreline? Okay, and it's just where the water is meeting the land. Don't confuse shore with shoreline. It's a lot, I know. Now, moving outward into the water, we have what's called the near shore because it's near the shore. And it extends seaward from the low tide line. So from the low tide line where all the waves are starting to break and crash over each other. It's never ever exposed to the atmosphere. This part is always still underwater, but it is affected by the waves that touch the bottom of the shoreline. Okay? Then you have offshore, and that's beyond all low tide breaker zones. And the water is deep enough that the waves rarely affect the bottom at all. Okay, so you have the back shore that's not usually underwater. Then you have the foreshore, which is where the tides are going to be hitting. Okay, then you have the near shore right here. You can see where all these little breakers are. Okay, and the near shore, the wave can touch the bottom, and that's going to help us make these longshore bars, which I'll talk about in a minute. And then you have the offshore, which the waves are not going to be touching the bottom at all. Check. All right. I do want you to draw this picture and label it in your notes. This is probably the easiest one to draw right here. Pause. Draw and label it. It's easy. Doesn't have to be colored. Hey, you can even print it and put it in there. Okay? All right. So now there's some more terminology for you. You have the berm, which is dry, gently sloping area that's elevated above the margin of the beach. What I always like to remember is you've got the dunes at the top, and then the berm here, and then you have where the water is going to be hitting. Okay? The berm is usually where you're going to go and play at the beach. You're going to lie in the sun, you're going to play volleyball, you have barbecues, you can have a bonfire, play frisbee, whatever. That is where you are going to be in the berm. All right, so you also have what's called the beach face. And this is the part that extends from the berm to the shoreline, okay? See it down here, the beach face. All right, and it's literally from the end of the berm all the way out, okay? And it's more fully exposed during low tide, but usually not exposed at all. This is a lot of times where runners are going to go when it's low tide because the sand is more packed and it's harder. Okay? Now, beyond the beach face are these longshore bars, and they're created by longshore currents. If you remember when we learned about the currents that run along the shoreline, okay, they run parallel to the shoreline. And it's not always present, but when one is there, they can be exposed during really low tides, and that's when you'll get these little tide pools, okay? Now, in the middle, between these little bars, and like you guys will call them sandbars, okay, there will be what's called a longshore trough, and that's where it goes down, where there's a little depression right there, okay? And it could be a series of that go alongshore depending on how many longshore bars there are. Remember that beaches are constantly changing. The tides and the weather can alter beaches every day, and beaches also are going to change seasonally. Think about summer beaches versus winter beaches, and that also is going to depend on where you are longitudinally or latitude, okay? So usually it depends on where you are, but light wave activities produce a wide sandy berm and an overall steep beach face. That's usually summertime, okay? But when there's heavy wave activity, it's going to take away all of that beach, and it's going to be much, much smaller, much steeper. Okay, so see this summertime beach with a nice sandy shore, and then here not so much. Okay, but they will have more sandbars. All right, then you have this intertidal zone, which I'm not gonna make you memorize these zones because it gets super complicated, and I already made you learn all about the berm and the near shore and the offshore, and I don't want you to hate me. But I am gonna show you because I don't want you to be like, she never showed us. This was when I would have made you memorize this in Rocky Shores, but I didn't get to. So let's look at it. All right, so you have what's called the supralittoral zone, and that's the backshore. Okay, then you have the high tide zone, which they call the supralittoral fringe. Then you have the high tide zone, that's only underwater during high tide. Supralittoral fringe is sometimes referred to as like the splash zone. Then you have the mid-tide zone, which is called the mid-littoral zone. Then you have the supralittoral zone and the sublittoral zone. All of those are different zonations that you can find at the sandy shore or at rocky shores. All right, so while movement occurs perpendicular to the shoreline, there's a movement that causes parallel to the shoreline too. And our waves are going to refract and bend and line up and parallel, and each breaking wave, the swash moves up and then the backwash takes stuff away. As a result, the water's going to move in a zigzag kind of fashion. When that happens, you get these longshore currents that move along and parallel to the shoreline. This one's a review. I know you know these, okay? Now, I know you know the rip current one too, because I taught you. The place where you think it's the most gentle right there, that is the place where you can die. Okay, and that's pulling away from the shoreline. And you remember, to get out of one of those, you can either go with it or you can go out to the sides. If you don't remember, there's some video clips for you guys. All right, we're getting there. Okay, so now we've got the different types of shorelines, and you can have erosional shores, which will have very well developed cliffs and are often in areas where the tectonic plates are going to uplift, like the U.S. Pacific coast, like California. So we don't really get these cool cliffs on our side, but they're really neat. Now, because of our waves hitting and refracting off of it, you can get headlands that jut out from the continent. And as the waves are hitting it, it can create sea arches and sea stacks and coves and caves and sea cliffs and even these things called blowholes. And it's really cool that you can see the headland is what's coming out from the land, and then as the water hits it, it's slowly going to cause these little weaknesses. Then a little piece will break off and it'll become a sea cave. Then it'll become a sea arch, and then eventually over time that arch will totally collapse, and then you'll just have a sea stack. And then over time the stack turns into a stump. Okay, so here are some pictures of some sea arches, and then over time that arch will collapse, and then you'll get a stack, and look right there, there's a little stump. Okay, now this is what's called a blowhole. Okay, so it's just after you've got that sea cave, there's a little hole in the roof, and when the wave comes in, it just shoots water out like a blowhole in a whale. Okay, those are erosional beaches. Now, the other one is called a depositional beach, and this is where sand deposits are made, and the land will actually grow instead of getting smaller. And here you get all these little different things that can form. The first one is called a spit, and it's a linear ridge of sediment that extends in the direction of the longshore drift. All these little sediments are getting dropped off at the end of a bay, and due to the currents, this spit is going to curve a little bit. And so here you've got a spit. See all the deposits that are being put down, and it curves because of the currents right there. Okay, and here is the diagram where the spit is. Okay, now over time, these can close off an entire bay, and so then they call it a bay barrier. See, and there's a picture right there of where it has fully closed off the bay, and so now it's a bay barrier. Other times, the ridge can connect a small island to the mainland, and so then they call those tombolos. I know, it's fun, isn't it? There it is right there in that diagram right there. Aren't you glad you aren't taking a Kahoot on this one? All right, and there are extremely long offshore deposits of sands that are parallel to the coast, and they're called barrier islands. And sometimes people live on them. Okay, look at that one. That's in Toms River, New Jersey. I used to live there. Okay, that's it. That's the end of part 3 notes. I know it was a lot, but I can't jip you out. You had to learn all about the erosional beaches and the cool sea features that can be made, like the arches and the caves. And then you had to learn about the depositional ones, where you have the spits and the bay barriers and the tombolos. I mean, you can't miss out on that. On a sandy shoreline, like, I can't rob you of that. There's one more section. It's not as long, and I'm just sad this is how our year is ending. Just know that I miss you, okay? And feel free to leave me messages on the bottom of your notes, because, you know, I'm looking at them. Tell me hi. All right. Miss you.